It's fun to talk about applications. Another application of electrochemistry is electroplating. All right, let's take a look what we got here. So we have an iron pipe, that's one electrode, a nickel, that's another electrode. But in this case, they both are immersed in the same solution, which is the nickel solution. Okay, if this were to be a regular galvanic cell, what's going to happen? Well, nickel, which is nickel 2. Ion, which has high, which is react with iron, which is relatively reactive. So this is going to happen. So iron will undergo oxidation reaction, become iron 2, so corroding the electrode coming out into the solution, right? And electron coming out, so going to go all the way to the other side. So nickel going to gain all electrons. And the nickel ion in the solution will go take that electron and start depositing on the nickel electrode. That's supposed to be like that. Okay, so it looks something like that. Okay, but here's what happened. If we apply the electricity, so right here, if we instead of the adding voltmeter in here, we use the battery. So we reverse the process using electricity. Okay, so we can drive the redox reaction go backward. So what happened is the nickel will lose its electron. Right, so coming out from the solution, the electron will go all the way to iron pipe, and when this happens, the nickel ion in solution will start depositing on the iron pipe. Okay, this is how we coat one metal with another metal. Give you some example. All right, now zinc pennies. A regular penny is usually made from copper, just a pure copper. You have seen this type of penny before. But in about 1980s, the price of copper rose, and it's too expensive to just make with too many pennies like made from copper, way too expensive. So they opt out to less expensive metal. So zinc, with this is solid zinc look like that. So they do zinc. And they use electroplating coat the copper on it, so it look like that. And that's what there's a copper coating around it. That. Another application of electroplating, so car which made of metal, and metal usually prone to corrosion or get rust. Get rust. Okay, depends on what type of metal they use. So they coat just a thin layer of palladium onto the car, like the car parts. And palladium is enough that does not react with oxygen or moisture in the air, and is resistant to heat and not very dense. Okay, it's harder than gold, so it's a perfect metal to coat on a car. All right. Okay, now let's do this. So electroplating is used to copper plate an iron spoon by placing it in solution containing copper 2 ions and connecting the spoon and the copper electrode to a battery. Write the half reaction that takes place when the spoon is plated with copper. Include phases. Is an iron spoon, the cathode or anode. Okay. If this were to be galvanic cell, of course, copper can oxidize iron, right? So iron gonna lose electron coming out to the solution. Electron gonna go all the way to the other side to copper, and the copper ion in the solution gonna go get on the copper deposit on the copper iron. Okay, also a copper metal. But when you apply the power source, the battery, you can reverse the process. So copper metal will lose its electron. Right, so coming out from the solution, electron go all the way to the iron side. That's it, become electrode. Copper 2 will go take this electron and become copper metal deposit on the iron spoon, and eventually we're gonna get that. There we go. That. Now, what happened on the iron electrode? Well, copper receive electrons and become copper metal. This is a receive, that's reduction, right? So in oxidation number is lower, so that's reduction reaction. This is the cathode. There we go. All right, one more. Fuel cell. Okay, this is another application of electrochemistry. Produce large amount of energy by just simple and cheap gases, hydrogen gas and oxygen gas, and water coming out. So this is so clean, no toxin at all. You know? That's so cool. All right, so there are 2 electrodes in here. Here's how it works. All right, so hydrogen comes in onto the anode side, right, and at anode, so hydrogen will lose its electron, get oxidized, right? So and become a proton. So a proton will pass through the membrane, right there, pass through the membrane. This membrane is only proton can pass through, so water or oxygen cannot pass like in reverse direction. Anyway, electrons go on to the other side, to the cathode, where oxygen approaches. Right, so oxygen gas come in, take the electron, get reduced, or take electron of course. So oxidation number could lower, become reduced, and oxygen with electron we go grab the proton to make water. Yep, grab proton to make water, and water comes out. Okay, so what we got is the large amount of electricity, and here we go. So William Robert Grove, he is a Welsh scientist. William Robert Grove, he published his paper about this fuel cell in 1838. He called it a Grove voltaic cell because it resembles the voltaic cell. Okay, but it doesn't gain a lot of interest until NASA. We have a spaceship program or something in 1838. Was it NASA developed program using fuel cell to generate power in a satellite and a spacecraft, capsule. All right. Some type of cars. So we have this one is Hyundai 2016. Okay, this side the car is powered by fuel cell. Okay, so this car is really clean. Use only hydrogen gas to fuel the car. Okay, that's a debate about it because hydrogen gas is flammable, so it's not that safe, but it's really clean. All you need is oxygen gas, hydrogen gas, making water and produce large amount of electricity. Okay. Anyway, so all right, one more class activity. So class activity number 5, we have 2 questions. The second one is electroplating, and that's the key. That's the end of chapter 14. One more chapter to go. I'll see you guys maybe tomorrow if you look at the video. Okay. All right. See you now. Goodbye.